today. So a quick introduction to our program. Welcome everyone to our currently named Ask an Expert series. And this is an initiative with Ocean Wise Research and Ocean Wise Education working together, one big happy family. So we're really excited to be giving you this opportunity to connect, find out what's happening with Ocean Wise Research, connect to our experts, and ask all of your questions. So again, we really look forward to seeing those questions coming through in the chat. Please feel free to select sending it to both host and presenter. That way I can see your questions, Lance can see your questions, and hopefully we'll get everybody's answered. You can also put questions in your Q&A box down below, and we'd love to answer those for you too. And we really want to acknowledge and start our program with how grateful we are to be presenting from Vancouver and the Lower Mainland, the traditional territory of the Squamish, Musqueam, and Tsleil-Waututh people. They have used the methods of storytelling and observation to communicate what's going on in their environment since time immemorial. And we are so grateful to be able to include that in our practice as educators, as researchers, and keep that honored tradition ongoing and learning from and with them in all the work we do. So it looks like we have a great group with us, and we're so excited to welcome Dr. Lance Barrett-Lennard to share his presentation with you today. So I'll put it over to you. I'm going to change over to the presenter status for you so you can show us your PowerPoint, but if you'd like to say hello, the floor is yours.
Thanks, Danica. Thanks everybody for tuning in. If you're like me, you're feeling, and I'm sure about 99% of the world is, feeling ready to for this whole coronavirus thing to be over. I was especially reminded of that somehow going through pictures to put the presentation together for today. This time of year, normally I'd be out on the water on the boat looking at resident killer whales and trying to figure out what's going on with them. But anyway, here I am, very happy to be here. I'll see if I can manage this sharing my screen and the presentation. There we go. Danica, that looks good? Great. Okay. So I have about a 20-minute presentation here that I'm going to whip through now. So the title of my talk that you probably saw online or on Facebook or something is The Mystery of the Declining Southern Resident Killer Whales. And I've added insights from the air because the work that a lot of the research that I'm the director of the Marine Mammal Research Program at the Vancouver Aquarium, which is part of Ocean Wise. Sorry, I lost my train of thought there, but the work we do is very much focused on conservation of populations in general and on the southern resident killer whales in particular. So I'll start with a little primer on the kinds of killer whale populations we have in BC. We're really lucky here in British Columbia in that we have a variety of different kinds of killer whales. And sometimes we refer to these as populations. Sometimes we refer to them as ecotypes because they they're different ecologically, they eat different food. But I guess the point is that we have different groups of killer whales that are completely exclusive of each other. They share the same waters, but they don't intermix. They're generally not hostile with each other, but they act like completely different species. And these four groups are the so-called southern resident population. These are fish-eating killer whales, mostly eat salmon, and they hang out in the summer months, typically in southern British Columbia and northern Washington state. We have the northern resident population, which is a little bit bigger population, a little over 300 individuals right now, whereas the southern residents only have just over 70. The resident killer whale, the northern residents are also marine mammal eaters, fish eaters. They prey on salmon like the southern residents, but they're found generally further north in the province, from about Campbell River, if you're familiar with Vancouver Island at all, about halfway up Vancouver Island. They extend from that area to the north in the summer months. In the winter months, both the southern and northern residents spread out and cover a bit more territory. And sometimes in the winter, their ranges overlap. In the summer months, they're generally not overlapping. But even when they do overlap, they seem to space out from each other. The bigs or transient killer whales, there's over 500 of those now in British Columbia. These are the mammal eaters. They're the ones that eat seals and sea lions and dolphins, porpoises, sometimes even larger whales like minke whales or occasionally even humpback whales. This population, as I say, is a little over 500, seems to be doing fairly well in the last 20 or 30 years. As seal numbers have rebounded from earlier efforts to cull seals and to reduce their populations, as seal numbers have increased, their principal food for transient or bigs killer whales, and the bigs have responded by increasing their population size. So if you were to take a whale watching boat these days from Vancouver or Victoria, you'd probably, and saw killer whales, it's most likely that these are the ones you'd see, the bigs killer whales. And then there's the so-called offshore population. Like the name suggests, these ones tend to be a bit further out off the coast, although occasionally they come inshore. There's a little over 300 of those that we know about. But beyond their numbers and a little bit of basic ecology, we don't really know very much about the offshores because we rarely see them. In any given year, there might be, between all of the researchers up and down the coast, and a lot of the whale watching companies have experienced naturalists that could recognize these guys. We only have a handful of observations every year. So we see the southern residents, northern residents, and the bigs killer whales very often. We feel as if we know a fair bit about them, but offshore is a bit of a mystery. And, oops, trying to go down. Let's just keep working here. Oh, sorry, operator error. I'm going to focus, the reason there's a red square around the southern residents is this is the population that I'm going to talk about mostly for the rest of the talk. It's listed as endangered, and it really is. It's quite critically endangered. Okay, so this is the only graph I'm going to show in this whole presentation, but it's an important one. I think the easiest way to understand it is to look here. You can probably see my cursor at this bottom part of the graph that says Chinook abundance. And this is from 1980 to the early 2000s, about 2004, I believe these data went to. And you can see that there's quite an annual variation in the abundance of Chinook up and down the coast. This is these bars in the Chinook graph are not exact counts, but they're an index of relative abundance. They give you a sense of how much salmon, how many Chinook there were from all of the different runs up and down the coast. And Chinook salmon, like other salmon, come from so-called runs that return to specific rivers. If we add all of those up, this is what this sort of aggregate Chinook index looked like for this period of time, late 70s to the early 2000s. So you can see there was a substantial period where there were more Chinook than average, and a substantial period when they were low. If you look above that to the SR mortality, that's southern resident mortality, you can see that mortality, that's the death rate of this population. It went through quite an increase, as you can see, during the same period that Chinook were rare. The same thing going up to the NR mortality, that stands for northern residents. We see the same thing approximately with the northern residents too. If you look a bit towards the left of these graphs, you can see that in the early 1980s, there was a period when Chinook abundance was fairly low too. It wasn't catastrophically low, but it was fairly low. And southern resident mortality went up during that period as well. So see low Chinook abundance here, higher southern resident mortality here. We didn't see that reflected as much with northern residents. But anyway, this simple little relationship was discerned by my friend and colleague and former graduate supervisor, actually, and John Ford, and it made a big difference. This one little relationship, it gave us in the science community some insights into what limits the number of killer whales that are out there. Ultimately, with most species, with it, food is going to become limiting. A population can't grow beyond a certain level because it'll run out of food. But often it's, before it gets there, it's limited. Its numbers are limited by something else. It could be predators, it could be disease, it could be climatic variability or something that keeps its numbers below its maximum numbers that could exist just based on food. But we didn't know what was going on with killer whales, but this gave us a sense that with resident killer whales, at least, they're very dependent on salmon, and so dependent on salmon that when salmon abundance goes down, their death rate goes up. So here we I just included the title page from a report of a workshop, a scientific workshop that happened in 2000 and a series of workshops that happened in 2010, 2011. And these were bilateral in the sense that there were both US and Canadian scientists who attended. The attendees were fisheries managers, salmon managers particularly, whale experts, lots of smart math heads, people who could look at statistics and tell us what it all meant. And we sat there and pondered and pulled on our chins and drank coffee and spent, probably between all the workshops, about 10 or 11 days, 60 or 70 people, trying to figure out, do salmon fisheries, human salmon fisheries, impact the southern resident killer whales? In other words, we knew already that southern resident killer whales were in poor shape. The question was, if we cut back on fisheries, would that help the whales recover? And of course, this was largely stimulated by the work that John Ford had done that I just talked about. It would seem very clear that there was a relationship there. It just made sense, it seems. If we cut back on fisheries, we should have more fish, and if we have more fish, the whales should do better. At the end of this whole series of workshops, we had some awesome models. Our eyes were fuzzy with models, but we failed. We didn't have any real conclusion. We came away from those meetings going, well, we could run all these fisheries models, and everybody's heard about all the models that are happening right now for coronavirus. When there's similar models used throughout biology for many different sorts of things, where you try to mathematically predict what's going to happen in the future by what happened in the past. But it didn't, there were no recommendations that came out of it, as I say. It just wasn't clear. And the intent of the workshops really had been to say, okay, based on John's work, we think that we believe that salmon abundance has a big impact. We now want to know which are the specific salmon runs that have the biggest impact, so that we can spend our dollars, our conservation dollars, trying to augment or improve or recover those salmon populations. So is a Fraser River salmon, the Chinook that are out there that head for the Fraser River, of which there are actually many runs in the Fraser, but was it Chinook return to the Fraser that are most important? Is that where we should put our effort in recovering salmon? Is it the Columbia River? Is it the Skeena River or the Nass River up in northern BC? We tried to sort that out and failed. And so, of course, the other way to put this less tactfully is scientists baffled. We came away going, oh God, that was a lot of work, and we've gone no further ahead. And of course, when you try to do something like this and you say, well, we didn't have enough data, or we couldn't really come up with a answer, a defensible answer based on the stats, people assume that there is no effect. Well, the scientists couldn't figure out what the impact of fisheries is on the whales, so that means there must not be one. Possible, but it's also possible that we just didn't do our job, or we didn't have enough data to do our job. So the problem, looking back on those workshops and the whole process, it's easy to see these things in hindsight. And at the time, we were all suffering from mass hypnosis, I think, on the science world. We all were so enthusiastic to solve this problem, we thought we could do it. But the only way, so what we were trying to do was to detect the importance of different salmon runs. And the only way we could tell if killer whales were negatively affected by the decline of any given salmon run was if more of them died when that run was in poor condition, right? So Fraser River salmon go into a couple of bad years. The killer whales go into a couple of bad years at the same time. Does their death rate rise? If it doesn't, well, then maybe it's not Fraser River Chinook salmon, maybe it's Columbia. That was the kind of logic. And likewise, the only way we could tell if they responded positively to an increase in the size of any of those runs, if we saw that more whales were born in those years when those runs were in good shape. Well, it failed. And the reason ultimately was, as I say, retrospectively, was that killer whales only die once. It's a very unfortunate feature of killer whales. It actually applies to a few other creatures as well. They only die once, and they're only born once. So that means we don't get very much data. If we, especially with southern residents, we have a population of only, 75, 73 individuals. If 5 or 6 die in any given year, they have very slow reproductive rate. So if 5 or 6 die, that's catastrophic. But of that 5 or 6 who die, 3 or 4 of them might have died because they didn't get enough to eat. One of them might have just been very old and got sick. Another one might have had an accident. So we'd only have maybe 3 informative deaths, how we would say in science, that would be likely to fluctuate from year to year based on salmon runs. Not much data. And so not much very little ability to see the impact of specific fisheries. In science, we would call this a lack of statistical power. We just didn't have enough statistical power to solve this problem. So the independent science panel, that's the panel that ran the workshops that I just talked about, in their final report, I think maybe the one thing that was most useful that came out of that report was independent science panel believes that photogrammetry to monitor seasonal interannual changes in the growth and body condition of southern resident killer whales is likely to lead the greatest number of new insights. So basically, they said births and deaths, it's not enough of them happening every year for us to get a lot of insights into what's going on. But the animals do get thin or fat. They don't always die if there's not enough food, but they are going to respond by getting more thin. And the beauty of this is that, as well as not losing whales, not having to wait till they died and to tell what's going on, is that animals can get fat and thin multiple times. And so you can get a lot of data. You can look at changes in growth from year to year and see how they're responding in a very sensitive way to their food supplies. So photogrammetry, what does that mean? Photogrammetry is a word that means measurements taken from photographs. So the idea was you fly over the top of the whales and you take a high resolution photo and you measure how fat the whale is, basically, how long it is, if you're interested in growth rates, and how fat it is. So I teamed up with my friend and colleague John Durbin and another friend and colleague, Holly Fehrenbach. Both John and Holly at the time worked for NOAA, the U.S. National Marine Fisheries Service. So they were scientists based in the U.S. and we'd worked together on a number of projects before, mostly in Alaska. Teamed up with John and Holly, and we decided that rather than try to charter helicopters to fly over the whales, which we couldn't possibly dream of doing because of this incredible expense. At the time, drones were just sort of appearing and becoming semi-affordable for researchers. And we thought maybe we could use a little electric-powered drone that we could launch from our boat, fly it over the whales, and take high-resolution photos. The one up here on the left, this APH-22 hexacopter that was custom built by a small company in the U.S. I think that was $25,000 for that little unit. We strapped a regular little point and shoot camera, well, fairly good one, but still, with interchangeable lenses. So we'd pick a intermediate size lens. It was very quiet and turned out to be very reliable too. And that's what we used for the first few years. And then as drones became more available and much cheaper for both commercial and recreational use, we bought this one. It's called the Matrice 200. It's just a fairly standard sort of low-level professional drone. It's a lot faster than the hexacopter and has much longer battery life and some other features. But anyway, that's the machinery. Here's our little research boat called the Scanna. It belongs to Ocean Wise and it's dedicated to our marine mammal research work. Here's John and Holly, myself driving, flying the boat, flying the drone off the back of the Scanna, and we, so that's what it looks like in the air. It's pretty tiny. We flew 30 meters, 100 feet roughly above the whales. We had a very accurate altimeter inside the drone, so we always was constantly measuring its altitude, which was important to know. And at that height, the whales didn't seem to have any sense that it was there. It would be like the size of a seagull. And And here would be quite a high seagull. They used to have seagulls flying low over them. Anyway, they didn't seem to respond to it in the slightest at that height. And we were comfortable working at that height for that reason. Often drones are flown a lot lower to try to get high definition photos, but we didn't need to do that. We had a good lens and good camera. It was very much a team effort, the field work, and continues to be. So we started this in 2014, and we're continuing it through to the present time, and hopefully for a number of years to go. Here's the view of our boat from above. This is my colleague at the aquarium or at Ocean Wise, Brittany Vasona. Brittany's flying the drone, launching the drone, and or perhaps hand catching it here. You can see she's dressed up like a ninja. She's got special cut-resistant gloves and wristers and a brush cutter's helmet, and yes, she's got a PFD. So she catches and launches the drone, and then when she's done that, she sits down and monitors the drone's camera, and then I'm the pilot of the drone, and Dylan takes over. Another colleague takes over the driving. So Brittany, Dylan, and I are the team these days. I still work with John and Holly. I collaborate with John and Holly, but we've sort of divided up. We have two boats now, and we work so we cover more territory, more time. So they cover the southern part of BC and Washington State, and we cover the areas a bit north of that. That's how the field work works. So these are the kind of photos that we get from the drone. And I thought I would show you how the condition of the whales changes. So 3 typical drone-based photos, the same whale, her name's J36. You can see of September of 2015, our second year of the study. This is what she looked like. So just burn that into your brain, what her shape is. Look at her over here in the following May. She's a lot thinner. You can see particularly this area, sort of the neck area. You can think of whales having a neck, just forward of the pectoral flippers, is really quite thin, whereas here she's quite fat across the neck. And then her body here, it's very robust. Here it's very thin. We were really worried about her when we saw this photo. But luckily, by September of 2016, it was summer feeding on Chinook, and so September was a reasonably good year for Chinook. She was in much better shape again. Here's another whale, or 3 other whales actually, who sadly ended up passing away. But these are photos we took of them in the previous few months, 6 months before they died. And you could see in all 3 cases that they're very, very thin. So again, the easiest way to see this is to look at the neck. You can see again that J28's neck was quite thin. I-63's neck was incredibly thin. Her eye patches sort of point in the wrong way. These white patches on the side of her head. And poor little J50 was perhaps even worse. You can see his big head sort of constrained by his skull, but again, very, very thin back here. And what we've come to realize is when whales get this thin, they almost always die. They rarely recover. J36 was a bit of an exception, the first one I showed you. Actually was the only real exception. It was quite that extreme. Here she is again. So we've learned that, and this is work that John and Holly really discovered, is that we can tell a lot from the eye patch. We measure the width of the whales down their body, but we don't always get photos in which we can see the whole body very well. We can't really see what's going on down here, for example, in this photo. But most photos we can see the eye patches and the head pretty clearly because of the way the whales angle their way up to the surface to breathe. And we can measure the width between the 2 eye patches. This part of the eye patch, the front part of the eye patch, is sort of right alongside the skull. So, and they don't put on much fat around the skull. So that this distance, EP top, doesn't change much. But the lower one is around the neck, and that one really does change. Depending on how fat they are. And the ratio of those 2, EP top and EP bottom here, it turns out to be a very useful measure. We can also measure head width, say, and compare that to blowhole to dorsal fin length. And we've done that. That ratio is also quite useful. But this one turns out to be kind of the gold standard. Again, work that John and Holly led in their analysis. And this shows these eye patch widths. Again, we can measure the total length in a good photo, and we can establish this eye patch ratio. So eye patch is very useful. Here's a photo of a fairly typical northern resident, fairly typical southern resident cow-calf pair, mother-calf, mother-calf. This is J28, so-called, and her calf J54 in good times, and A75, northern resident female, and her calf. And what you can see here is, look how nice and robust the mother is here. She's definitely fatter than J28. But the real take-home message from this slide is these calves are exactly the same age. So here you've got one that looks a nice calf that's very robust, that's probably well over half the length of its mother. And here, poor little J54, very thin and very short, as well as thin compared to her mother. So really what we're seeing here is the growth rate of the calves, both their length to some extent, and particularly their width is much more rapid. These calves are exactly the same age. And there's a striking distance. The northern residents seem to be doing much better in general, body condition wise, than the southern residents. I thought I'd throw in a quick picture too of the difference between the Biggs killer whales and typically and resident killer whales in their body shape. So here's a fairly robust southern resident, J2, an old female. She passed away now, but when we took the photo, she was in very good shape for a southern resident. And here's a transient in comparison. Look at the difference between them. You know, this transient is so fat, it's just massive. You know, look at his neck, just massive compared to the resident. And his chin is so fat that you can see his chin is white. You know, if you look at a killer whale upside down, its body is white. Chin is white, and his chin is so fat and he's so jowly that his jowls stick out on either side of his head. And just kind of rolling in fat, really. And here's this, you know, really lean resident. Sorry about that. So again, you know, those jowls are indicative of a whale in really good shape. So quickly moving on to take-home messages from this study. So as I said, we started in, maybe I didn't say, we started in 2014. Our last season, of course, was 2019. And we, if coronavirus shutdowns allow, we'll be out there again in the later part of this summer of 2020. So what have we learned in this time? Well, we've learned that we can measure body condition quite accurately from these photos. And we've learned that these eye patch ratios are kind of a quick and reliable indicator of body condition. We can get accurate, precise eye patch ratios from many of our photos, whereas we have to have really good photos to get length and width. And we try to take as many photos as we can over a fairly short period of each whale, and then we do the measurements repeatedly to look at any kind of error that we might get. We might get error if the whales are slightly tilted, for example, they're coming up to the surface on an angle or slightly rolled over to one side, or if we know which we do, the magnification factor of the lens, and we know the precise altitude of the drone, then we can measure these lengths very, very accurately, as long as we have a good photo. We've confirmed that the winters are hard, and this is something that we argued about at the bilateral workshops that I mentioned. We didn't really know at that time, did the whales tend to come into better condition in the summer months, or did they actually put on weight in the winter? Are there more chinook around in the winter? And then the summer is kind of a fasting time for them. That's important to know if you're worried about fisheries, because fisheries take place at different times of year. Anyway, we confirmed that the winters really are the hard time. This is what many of us suspected, and it's turned out to be true. So the resident killer whales usually put on weight in the summer. Almost every year they put on weight in the summer, and they usually lose it in the winter. We've determined that the southern resident killer whales have declined in average body conditions substantially since 2008, and the J-pod is usually, in most years, is the thinnest. Southern resident killer whales have 3 pods or family groups, and one of them is called J-pod, and it is the one that's most local. It tends to spend its winters in fairly close to Vancouver Island, and the other 2 southern resident killer whale pods range further in the winter. Anyway, J-pod is usually the thinnest of the 3 southern resident killer whale pods. We've learned that although Chinook are very important, we went into this knowing that they feed on Chinook primarily. We've confirmed that coho and chum are also important, particularly in poor Chinook years. And we already knew that chum were important for about a month a year when the chum come into their fall runs, and usually in October. The killer whales and resin killer whales sometimes switch to chum for a few weeks. We didn't really quite realize how many coho were taken as well. But anyway, those seem to be the three important salmon. The Chinook, with Chinook still far out in advance. We've learned that many pregnant females don't calve successfully, so we can tell quite easily from the photos when a female is pregnant if she's more than about 5 months pregnant, and gestation is about 16, 17 months. So we've learned that many of these females that we see being pregnant, very clearly pregnant, show up a requisite number of months later without a calf. And so they've either lost that calf through a late-term spontaneous abortion or miscarriage, if you like, or died as a very young neonate, as a newborn, before anybody saw it and documented it. So this appears to reflect nutrition during pregnancy. That thinner females have a harder time bringing a calf full term and keeping it alive when it's born. And then, as I said, we can tell from how thin the whales are whether they're likely to die. So our point here is that these deaths are predictable based on body condition. And body condition can be affected by a number of things. It can be affected by disease. It could be affected by a condition like cancer. It could be affected by an accident that broke off a bunch of the whale's teeth, so it can't eat properly, say. All of those things can cause a whale to lose weight, but what always causes anything to lose weight is not eating enough, right? So the most parsimonious, if you like, or the most likely explanation is that these whales are going into poor condition because they're not eating enough. In some cases we might be wrong, but we're very likely to be right in a lot of cases, and that we can tell that based on their body condition. And then finally, we've seen that from the air that fishing vessels can reduce the foraging success of nearby killer whales, and this is something that is very clear to us when we look at it from the air, and not always as clear to people down in fishing boats. But the resin killer whales often chase salmon up to the surface and circle around. You can see these energetic chases. They use the surface of the water as a kind of wall and confine the movements of the salmon. And if there are fishing boats nearby or any vessels very close to them, the whales usually often give up and just simply move away. They abandon the chase because it seems that they don't like to risk hitting or coming very close to a vessel. So people in the boat can get a great show and see a salmon chase, but what they may not realize is that they're often interfering with that chase and preventing that whale from catching a fish. So there's that kind of direct effect of fishing. But there's also the other effect, the one that we probably think of most first, and that is we've seen the body condition changes are correlated with changes in salmon abundance. Generally, when salmon abundance goes down, the whales do get there. This is really was the whole point of the study, I guess, was to determine how tight that relationship is. And of course, because fish abundance, particularly near the mouths of the rivers, is of these adult returning salmon is affected by fishing vessels, particularly ones in those that fishing in the same area. That fishing activity certainly impacts the whales. Is it a huge impact or a small impact? We don't really know, and it may take some time to figure it out. But we don't have much time. Southern residents, only 73 whales. We'd love to be able to sit back and say we need more data, and we'll look at this, and we won't act until we have a better picture of the story. But we don't have that time, so we're acting in a precautionary way. So the conclusion, anyway, as I said, is that salmon fisheries do impact southern resident killer whales. So what's happening as a result of this? So the findings from our work from this photogrammetry study have been shared, of course, widely, and with the Fisheries and Oceans Canada in particular. The salmon managers have been great to work with, I have to say, at Fisheries and Oceans, or as we call it, DFO, Department of Fisheries and Oceans. And they've responded by restricting fishing in certain key areas. So I won't go into where these maps are exactly, but the areas, these are in southern BC, you know, in the approaches to the Fraser River, where the southern resident killer whales spend much of their summer time in the summer months. And the areas in yellow on these maps are places that are closed now to sport fishing. There's no commercial fishing in these areas anyway. So if there was a commercial Chinook fishery in this southern part of BC, then that would almost certainly have been closed as well. But that's not the case. So so the focus is on sport fisheries, and there's quite heavy sport fishing pressure. Another measure that's been brought in to try to protect the southern residents is that the closest legal approach distance now for boats is 400 meters in the waters shown in dark red here. So the or the color generally, sorry, the whale watching, commercial whale watchers have entered into most of the companies into an agreement with the government whereby they follow various rules, and they're allowed to approach a little bit closer, allowed to approach Biggs killer whales a little bit closer. Basically, they can tell the difference. If they have experienced naturalists, the whale watching companies can tell the difference between Biggs and resident killer whales. For the average boater out there, they can't. It's a subtle difference. So the whale watch companies can approach a little closer, but approach Biggs a little closer. But this is a big change. 400 meters closest approach distance for all southern resident killer whales, and is a big change. For many years, there was no absolute guidance on this from the government. No established closest approach distance. And but there was a prohibition against harassment, and 100 meters was used as a measure of harassment. And now we're up to 200 for all cetaceans in Canada and 400 meters for killer whales in this area. So a fairly significant change. And then sanctuary zones have been established. And these are places along the southern BC coast, again, in the same area, same general areas as where the fisheries closures are, that restrict all vessels, with some exceptions. Kayaks and people returning to their homes and whatnot can transit through these areas in their boats. But these are basically boat-free zones. There's a big one out on the so-called Swiftsure Bank, between the outer part of the coast between Vancouver Island and Cape Flattery on the US side. And there's one near Pender Island, Southern Gulf Islands, and another near Saturn Island. So so these sanctuary zones are intended to give the whales a place where they can go and forage and not have to worry about vessels being close to them, even 400 meters close to them. The federal government's also brought in some, or requested that some voluntary measures be observed, and these would include slowing down to 7 knots or less within a kilometer of whales. Turning off sounders is really easy and really important because the whales can hear your depth sounder, and then idling your engines if the whales are within that closest approach distance. So thank you very much. I think the take home, the final take home is that you know, we are very concerned about southern resident killer whales. We're more and more convinced that the reason for the decline has to do with the scarcity of their main food source. And I'm happy to say I've sometimes been critical of government or was in the past about it being slow to act on some scientific recommendations for whale conservation, but I must say I think they've been very proactive in the last couple of years in BC, trying to bring in measures to protect the southern resident killer whales. So thanks very much. That's the end of the talk. And I guess now I take questions. Danica, is that right?
That would be fantastic. We have so many wonderful questions for you. The chat and the Q&A has just been coming alive. I noticed one question that several people had was if there was a seasonal relationship to the mortalities that you were seeing. So it sounds like lots of people had some questions about that.
Yeah, that's a good one. Yes, there is some seasonality. We tend to see most of the well, we don't see them usually, but most of the mortalities, most of the deaths occur in the winter. So there's a lot of interest every year when, the whales, because the whales, as I said, the southern killer whales tend to spend their summer months in these areas where they can be seen fairly frequently and counted. And of course, they're all individually identifiable based on their markings, and a lot of the whale watching company naturalists are quite good at identifying them, and as is the research community. So we know a fair bit about what happens in the summer months, and we don't see a lot of deaths in the summer months. We see a few, but typically they go away, or we stop spending much time in the water because it gets nasty. The weather gets nasty. The few people who are out there report that the whales are really just not around in the same areas much in the wintertime, and they come back in the spring. And we're always very interested in doing a count as soon as we can, because that's when they tend to lose the individuals. So we don't quite know why there's that winter mortality, but as I said, we know that summer is the time they put on fat and gain body condition, and they slowly lose it during the winter. So it could be related to that. There could be some accidental deaths in the winter too from storm conditions or other things.
Awesome, thanks so much. And I know that you mentioned that you've been seeing some feeding on both chum and coho, but there was also a few questions about, have we seen them adapting their diet to anything else? We often hear about even like harbor seals and various seal species being very abundant around here. Could they change their diet?
Yeah, well, that question about why they have such, narrow ideas about what food is the thing that got me interested in killer whales, in the first place 30 years ago. They don't act like normal animals in a way. They act like very picky, 5-year-olds who will only eat, hot dogs and Pop-Tarts or something. They have very, very, very strong dietary preferences. And one of the things that was striking about John Ford's paper showing that when Chinook declines, mortality declines, I think a lot of us looked at that and we went, why the heck don't they? Big killer whales are out there scarfing down seals left and right. Why don't the residents start eating a few of those? They're just because salmon goes down, they're starting to starve. What kind of wimps are they? And so this strict dietary preference is a feature. It seems to be a feature of killer whales worldwide, and I could talk for hours about why I think that is, but there's no very, very strong scientific consensus on what that might result from. There's a lot of interesting theory, but the point is, no, they don't seem to adapt very much. They'll shift diets within their normal dietary range. So I would say chum are normally part of their diet. Coho appear to be normally part of their diet. If there aren't many Chinook around, they really go looking for chum and Chinook. I mean, chum and coho, but they still don't go looking for harbor seals or ocean sunfish or hake or something like that,
Awesome, thanks so much. And there was a lot of curiosity too from our audience about how much salmon does an adult killer whale actually need to consume to be a healthy body weight?
Yeah, so they need to, there has been some good work done on that. They need to have about, of course, it depends a lot, but, lactating females need the most food. Adult males are quite a lot, probably twice the mass of adult females, so they need to eat a lot. But if we look across the whole population, average all both sexes and all the sizes of animals and then weighted by their abundance in the population, it works out to about 80 kilograms a day. It would be an average, what a killer whale on average needs. So a good sized Chinook, could be easily 10 kilos, could be substantially more. So they could eat on the order of, 6 to 8 to 10 salmon a day. Certainly in some areas places where they're scratching to try to get small salmon, they'd have to eat more than that, but that gives you a rough sense.
And then one question that just came in as well is, has anyone ever looked into their DNA or physiology that might indicate why killer whales have such varied diet preferences between populations?
Good question. There has been a bit of So my group at Ocean Wise, one of the things that we do in our spare time in the winters is a lot of work on killer whale genetics. We haven't looked at that question specifically on whether there might be something in their genes that predisposes them to a particular kind of prey. But there is a researcher in Europe who's done a bit of that work, a guy named Andy Foote, and Andy's shown that that there does seem to be some adaptive commitment, if you like, so some very small genetic differences between killer whales in the North Atlantic that eat marine mammals versus those that eat fish, and that those genetic differences are adaptive. So they affect things like the amount of calcium, the strength of the teeth, essentially, and their ability to digest certain kinds of prey. But these differences are small, apparently, and certainly here I had a student years ago named Carissa Fung, and Carissa looked at compared the skulls of residents and transient killer whales and found that transits or Biggs killer whales, I call them transients because I'm old and that's what we used to call them, that these mammal-eating Biggs killer whales have more robust skulls than the residents. Not surprising, but again, that would reflect some sort of commitment perhaps to taking large prey. So whether they developed the dietary preferences first and then began to evolve some secondary adaptations to be better at it, or whether the adaptations happened first because the whales are separated in different parts of the world, perhaps, we don't know the answer to that.
Thank you. There are definitely a lot of mysteries. A lot of questions too that have been coming through is with various protections that have been enacted, how does Canada's protections compare to US protection measures? Can you shed any light on those?
Well, I'd say we've had good cooperation with the US on the West Coast, especially. So the two fisheries notions and the U.S. National Marine Fisheries Service on the U.S. side of the border, that's responsible for so-called management of marine mammals in U.S. waters, have cooperated pretty well. So our regulations aren't the same, but they do try to keep them as similar as possible. So, for example, we had a 100-meter sort of common law closest approach distance, as I mentioned, to cetaceans in Canada. Well, they brought in on the US side, they brought in a 200-yard approach distance. And then we upped ours to a 200-meter approach distance, except in the case of killer whales where it went to 400. So that would be, and that was not coincidental. That was done because it really does make sense, I think, to coordinate as much as possible. I think our fisheries, our restrictions on fisheries are a bit, sport fisheries are a bit stronger than in the US, although they have had some pretty substantial fishing restrictions brought in there too, just not brought in by the federal government, brought in more by local governments. The rules on vessel approach distances are a bit tougher in Canada than they are in the US now. Not just the approach distance, but the behavior of vessels. So I think there are some differences between the two countries, but generally there's pretty good cooperation across the border on that, I'd say.
Awesome, thank you. And I know we're just coming up to kind of the end of our time with you. And one of the questions that a lot of the audiences has is kind of, what can individuals do? Can people do anything to help either support the sustainability of salmon or help these southern resident killer whales out?
Well, I'd say one of the things that I could say that if you're a boater or a sports fisherman would be to follow the regulations and the guidelines and voluntary measures very closely. That's an easy thing to do. It's a very important thing to do. It's the most tangible thing I think that anybody can do. Whales are struck by vessels as well from time to time. Killer whales are pretty good at avoiding ships, but and boats, but they're very long-lived, and they may happily and successfully avoid boats for 20, 30, 40 years, but if they screw up once and get in the path of a boat and get hit, then that's a significant impact for the population. So so it's really important to be not only to not approach whales that you can see closer than those distances, but to be alert, to be really aware of them. We've done a lot of work with educating people, coast pilots and the operators and bridge crew of large ships on this issue. And recreational boaters can do the same thing. So that's what you can do if you're a boater. If you're not a boater, I think certainly I wouldn't eat Chinook from caught in local waters myself. That's a personal choice, of course, but there are sustainable Chinook fisheries elsewhere. Sometimes you don't know where the fish is from, but personally, that's a decision I made a long time ago. I think it's always important to lobby government, or to at least not necessarily lobby government, but to make sure the government knows how you feel. So when you vote, if you're at all candidate meetings, or if you write to your MP, I think it's really important to give them the feed, to constantly remind them that as a member of the public and a member of the electorate, you care and you're watching them. As I say, I think they've been doing a pretty good job the last few years, but they respond to public opinion, and it's really important to make your opinions known on this one.
Wonderful. Thank you so much. Another kind of theme in some of our questions that have been coming through is, do you think there might be signs of improvement in this population? Do you have hope that it will grow?
I wish I could be optimistic and say yes. It's still very much, this population is still very much, very critically endangered. I guess it's really not out of the woods. We just haven't seen a positive growth trajectory for quite a few years now. We've seen the population decline several years ago and not even more and not recover. So it's very vulnerable at this age. An oil spill, for example, could wipe out the whole population. Or even if it wiped out, 10 animals, that would be, and some of them were reproductive females, that could have a huge impact. Killer whales reproduce really slowly. Females only have a calf once every 4 years, typically, and they only want 4 to 5 years, and they only start calving when they're, 13 or so, 14. So every life is precious, when they lose an animal from the population, it takes a long time to replace it. So I don't consider the population doomed by any means. I think the 73 is a number that they can recover from. We've done some work on their inbreeding levels, and yes, they've lost some genetic variability, but it doesn't seem to be a crisis yet from that point of view. So what they need to do to be able to survive in the long run is to start to recover fairly quickly before they become too inbred. That's why all these measures that have been brought in the last few years are so very important. If we stick to those measures, if they continue to be implemented, if we keep a very close eye on the whales so that if they become thinner, we can further restrict salmon fishing, they've got a chance. That's about all I can say.
Wonderful. Thanks so much. Well, there are so many great questions, and it maybe just proves that we'll have to do this again, because we are coming to the close of our time with you today. But I always like to conclude our programs with asking kind of, what advice do you have for the next generation of scientists or conservationists? Any tips or tricks that you would have for pursuing their goals?
Oh, tips and tricks. Yeah, I would say if you're a high school student or an early, an undergrad university student, for getting into a field like mine that involves both field work and data analysis, you pretty much have to have a university degree to get paid for this kind of work anyway, and you might be able to volunteer otherwise. When we hire people from time to time, and what I always look for are candidates that have a variety of skills. So I get a lot of applications from people who say, I love whales. I've always loved whales since I was a kid. I did a general degree in biology. I'd really like to work for you. And unfortunately, I can't hire those people very often because I've usually got some specific need where I need somebody who knows a lot about marine mammals, but is also really good at statistics, or really good at biochemistry, or really good at genetics, or is really good at running boats, and they can come out in the field and drive our boat. You know, we hired Dylan, who I mentioned earlier on, to be our boat driver, and we hired him with the intention of keeping him for 4 weeks. And after 4 weeks, we couldn't let him go. We had to hire him permanently because he was so good at his job. He was good at the acoustics, recognizing the whales based on their sounds, and very good at the photo analysis, and he had just a perfect set of skills. GIS is a very good field to be in right now too, if you want to do this kind of work. I think geographic information systems, where you look at spatial patterns in the distribution of animals. So I would say plug some sort of specialty onto your onto your degree when you go to school, when you go to university, and it'll help you a lot in the long run. And then kind of volunteering can help for sure. Summer jobs to get some experience can be very, very helpful. A lot of people who've come to work for us have put in some time working for whale watching companies. We've got some very good people who've done that. That helps.
Wonderful. Well, thank you so much. And thank you for being able to stay on a little longer with us to answer some of those great questions. And a big thank you to our audience that also stayed on a little past 1:15 today, and for asking all those fantastic questions. We really want to stay connected with you and learn more from you, as well as, you know, being able to share the great work that Ocean Wise and Ocean Wise Research is able to do. So thank you so much, Lance, for sharing those great insights with us, as well as, you know, explaining some of those mysteries of our southern resident killer whales. And as we come to a conclusion today, again, a big thank you to our audience. If you enjoyed the program and you want to find out more opportunities to connect with us, we would love to have you visit ocean.org/learn online, where you can see our various live streams and weekly offerings, as well as we have lots of opportunities to stay connected with us, whether it's visiting education.ocean.org to find out what we're doing, or following us on Twitter at OceanWiseEDU. You can follow along and learn lots of great resources. We had some resources being shared in the chat today, so that's always wonderful to see all the different ways that you can stay connected. And as you have perhaps heard in the media lately, the Vancouver Aquarium and Ocean Wise really does need our community support, and we would love for you to share these opportunities. If you'd like to use the hashtag OceanWise, hashtag Ask an Expert, or tag us in your posts, get the word out to your audiences so we can continue to grow these programs. That's always greatly appreciated. And if you enjoyed this program and you are able to make any small or large donation to the organization, every dollar really counts towards supporting the work we're doing and going to reopen the doors of the Vancouver Aquarium. So you can find out more details about supporting Ocean Wise, the great work that we're doing, like Lance's work, as well as looking after the animals in our current care at vanaqua.org/SaveVA. So we hope to hear you out there, see you at our next program. Our next one coming up is going to be at 11 a.m. tomorrow with our live from the Wet Lab biologist talks. And our next Ask an Expert program is next Thursday at 1 p.m. with Fiona Beatty. So we're really looking forward to another wonderful presentation. So we hope to see you there. And on that note, we'll give you a wave goodbye. We'll shout out another big thank you to Lance, and we'll be signing off.
Thank you, everybody. Bye-bye.
Bye.